All right, let's look into the questions from Get Equipped section, Get Equipped to Advanced section of Chemical Equilibrium booklet. So the first section within this is fill in the blanks, and in that the first question is about this. Just a minute. A tenfold increase in pressure on this reaction causes what to the equilibrium constant. Now, as we are aware about that, the fundamental factor which affects K is temperature only. That means what will be the answer here? That a change in pressure would do no change in Kp. Right, pretty simple. The second question asks that for a gaseous reaction 2B goes to A, the equilibrium constant Kp is fill in the blanks than Kc. Now, gaseous reaction likha hua hai. That means both B and A are gaseous, and delta Ng here is -1. And we know the relationship between Kp and Kc. Kp is equal to Kc into RT raised to the power of delta Ng. Right? So a negative value of delta Ng implies Kp is less than Kc. Then the next question, the third question is slightly difficult, although not something which is not doable. थोड़ा सा language इसमें समझने का जरूरत है. So it's a question related to the disturbance happening to the equilibrium. Right, you understand that there is an initial equilibrium and then the volume got doubled, right? This is your disturbance. As a consequence, what would be the new equilibrium and the partial pressure of NO2 at that new equilibrium? So we follow our approach, systematic approach that we have. We first write the reaction, NO2 or N2O4 gives 2NO2 gas, right? We talk about initial equilibrium here. 4P0 is the partial pressure of N2O4 and NO2 is at a partial pressure of 2P0. Based on this, if I calculate Kp, right? Pucha nahi hai, but we all know that it's good to know, it might come of need going forward. So it will be 2P0 square upon 4P0 and the answer comes out to be P0 itself. Now notice karna, the disturbance, right? This is the catch over here. This is the important thing, that the volume is doubled. Now, when I say volume is doubled, what would happen immediately to the partial pressures, right? They will get reduced, right? They will get reduced to half, right? This is an abrupt change that occurs due to disturbance. This becomes 2P0 and this becomes P0. As a consequence, shift happens. Now, in which direction the shift would happen? Right? That is something which we can analyze subjectively or numerically, right? Using the relationship between Q and like QP or QC. Or subjectively, we can say volume double ho raha hai, pressure kam ho raha hai. So the equilibrium shifts towards more gaseous moles, which is forward direction. Right? So yahan par say -x and plus 2x is the shift that happened. And as a consequence, new equilibrium got attained, which was 2P0 minus x and P0 plus 2x. How do we solve for x? Right, we solve for x using Kp, right? A quadratic will be there. We will have to solve that quadratic. Now, I'm not going to do the mathematical steps because it's just plain simple calculation. But the answer is not really x. The answer is P0 plus 2x. That is what the answer is. So you solve the value of x from the Kp expression and get the value. And here m and n, like the expression which is mentioned over here, these are digits, right? So if the answer comes out to be like root 43 minus 3 upon 4, right? Then m would be 4 and n would be 3, right? Digits are to be reported. I'm not sure what the answer exactly was. Like I'll have to solve, but this is how you have to read this expression. Okay. Now, moving on to the next question. It's a true and false question, which talks about if the equilibrium constant for the reaction A2 plus B2 giving 2AB is K, then what will happen, right? And that for the, okay, it's asking then what will be the equilibrium constant for the backward reaction? Is it 1 by K? Like it's not backward reaction, it's just written in a reciprocal manner. So the answer is it's false, right? In fact, it will be 1 upon root K, right? So we have done, reversed the equation. As a consequence, the K becomes reciprocal, K raised to the power of -1 happens. And of course, we have also divided by 2, right? The entire equation has been divided by 2. So raised to the power of 1 by 2 also goes into the power of K. So the actual answer will be 1 upon root K. Now let's move on to the one option correct questions. In this, the first question is pretty similar to the question that we just did above, this third question. Now, rather than directly giving the data for N2O4 and NO2 at the initial equilibrium, what they have done is they have given some indirect information, right? So what they have done is that it is at initial equilibrium, right? The total pressure has been given to you as 3 P naught, and you have been given that the Kp is 0.5 P naught, right? So if I was to take this as X and Y, that means X plus Y equal to 3 P naught, and Y square by X is equal to 0.5 P naught. That would, when you will solve, you will get X equal to 2 P naught and Y equal to P naught. Okay. So rather than giving the initial equilibrium data directly, they have just chosen to give that indirectly, right? So okay, once we have understood that, then we follow our same thought process. After initial equilibrium, we understand the disturbance that happened over here, right? And yahan par the volume was halved, right? So what is going to happen to the partial pressure abruptly, right? The abrupt change means the partial pressures are going to be doubled. Volume is halved. So ye 4 P naught ho gaya, and this became 2 P naught. Now, after this, the shift happens. Which direction will the shift happen now? So again, you can think subjectively or numerically. Pressure here was, volume was reduced, right? So pressure increased. So the shift happens towards the lesser gaseous moles, which is in this case backward direction, right? So you take backward as the shift. So this becomes -2x and this becomes +x. And as a consequence, you arrive at the new equilibrium. So new equilibrium is 4 P naught plus X and 2 P naught minus 2X, right? Now, how do you go about solving for X? Well, you know expression of X. Solve X using Kp, right? So again, it will be a quadratic. I'll not get into the solving part of it because that is something which you will have to put your efforts into. And once you get that, your answer is the new pressure at equilibrium, P total, right? At new equilibrium, which is this entire thing, right? So it is 6 P naught minus X. So you get the value of X and you put it over here, and this would be your answer. Right? Then next question, the second question. It is about 4 moles of mixture of Cl2 and N2 is added in a 20-liter vessel, which contains 1 mole of PCl5, 2 moles of PCl3, and 3 moles of Cl2 at equilibrium, right? So again, a disturbance wala question. So PCl5 gas is in equilibrium with PCl3 gas and Cl2 gas, right? Now, don't forget about the volume part. So you have initial equilibrium in which, I'm right now doing mole analysis, but I'll not forget about the volume. when I am going to be writing the expression of K. That is a very common careless mistake which students can do. So initial equilibrium, you have 1 mole of PCl5, 2 mole of PCl3, and 3 moles of Cl2. So Kc here would be 3 into 2 by 1 into 1 by 20. Right? I have to take care of the volume. Now a disturbance here is in terms of 4 moles of equimolar mixture of N2 and Cl2. That means 2 moles of Cl2 was added and 2 moles of N2 was added. Now N2 here is not going to participate in the reaction. This is going to behave like an inert gas, right? And since there is nothing mentioned about volume change happening, so we'll say that it is inert gas added at constant volume, and we know that it does not have a disturbance effect when inert gas is added at constant volume. हम लोगों ने theory में we have studied in this LCP section, Lee-Chatterley's principle. So with this disturbance, because of the Cl2 added, the shift happens in the backward direction because the product was added. So minus x, and plus x. And as a consequence, new equilibrium, you have 1 plus x, 2 minus x, and 3 plus 2 minus x. That is 5 minus x moles of Cl2. Now, how do we solve for x? Well, the answer is pretty simple. We use the expression of Kc. Right? Solve x using Kc. Right? So I'll just form the expression, not solve it for you. 2 minus x into 5 minus x upon 1 plus x. And of course, the volume remains 1 by 20. Oh, my bad. I took the wrong value of Kc. Kc was 3 into 2 by 20. Right? 6 by 20. So yes, now after solving this, we'll get the value of x and the mole fraction, right? This is where the N2 things is going to come of use. Mole fraction of N2 will be moles of N2 upon, we are not being asked mole fraction of N2, we are being asked the mole fraction of PCl5, right? Yeah, PCl5 will be moles of PCl5 upon total moles, and this is where N2 ka rule will come, because the total moles are going to be moles of PCl5 plus moles of PCl3 plus moles of Cl2 plus moles of N2 as well, right? The 2 moles that were added, right? So this is going to be our answer. Again, not solving till the end. I'm sure you will get the gist of it. Third question. That is something which, we consider the dissociation of these gases, and what is being asked about is the average molecular mass, at equilibrium. Is this, or this? So at the first look of it, question is difficult because there's a lot of, you feel lack of information. But what is happening over here is that the average molecular weight of an equilibrium mixture must lie within a range. And you'll have to check whether the values given are supposed to be inside the range for the reaction or not. So let me illustrate that better with one of the examples. So let's say option A, in which the equilibrium or the reaction will be SO3 dissociating to give you SO2 plus half O2. Right? Now start and equilibrium. You can say 1 mole. Okay, no hard data. So we can do the mole analysis by starting with 1 mole, right? Nothing, right? And say in the end, okay, assuming that the reaction would have gone to completion, 1 mole of SO2 and half mole of O2 would have been there. Of course, if equilibrium was established, then 1 minus alpha, and alpha by 2 is something that would have written. However, if I now focus on this mixture, right? The initial mixture, the molecular weight will be because of just SO3 being present, right? We have just SO3 to begin with in this mixture. So the molecular weight is just 80. Right? And in the end, if let's say the reaction was going to completion, then what would have been the molecular weight? You can apply the formula N1 M1 plus N2 M2 upon N1 plus N2, your total mass upon total moles, a formula that you learned in mole concept. So 1 into 64 plus half into 32 upon 1 plus 1 by 2. Upon solving, you get this to be 160 upon 3, which is roughly 53.33. Right? As a consequence, this is the range in which the molecular weight of the mixture would be present in. Right? If alpha is 0, then molecular weight is 80. If alpha is 1, like complete reaction has happened, then the molecular weight of the mixture would have been 53 by 33. Right? Since the data given over here in this option lies inside this range, right? It falls inside this range of 80 and 53.33. That means this is acceptable. This can be the, oh sorry, it isn't in that range, my bad. It isn't in that range. That means this is not an acceptable answer. That the value of 50 is not between these two values. As a consequence, this option is incorrect. The average molecular weight of the mixture cannot be 50. Right? Similarly, you will have to go and quickly check each option one by one. There is no other option. There is no other way. You will have to check these options one by one and get the answer, which, you can do it in a bit faster manner. Like if you are well practiced with the formula and calculations, but otherwise, thoda sa time lagega hi sahi. Like you'll have to spend some time into this question. Okay. Now let's look at the next question. So in this, as you can see, 2 moles of PCl5 is heated in a 150 liter vessel in presence of 1 mole of neon. Right? Again, neon is inert gas. It is not going to participate in the reaction. The role it is going to play is in the mole fraction. Right? In the calculation of mole fraction, denominator mein moles of neon become. Right? Now, what it's saying is that PCl5 upon heating, it gives PCl3 plus Cl2, right? And it is present in a constant volume vessel, 150 liters का volume का vessel दिया हुआ है, 2, nothing, right? This is your start. Then say some X moles dissociate, plus X, and at equilibrium, you have 2 minus X and X, right? And mole fraction of ammonia, sorry, not mole fraction of ammonia, sorry, mole fraction of Cl2, that is moles of Cl2, X upon total moles, 2 minus X plus X plus X plus 1 mole of neon was 1 by 7. तो यहाँ से आपका X का value आ जाएगा. And यहाँ से you will get the value of Kc also. Kc will be X into X upon 2 minus X into 1 upon 150. Right? Volume को नहीं भूलना है. So you will get the answer to Kc as well. Right? Now, since the temperature is same for both the reactions, as in for both the situations, the reaction is actually the same. For both the situations, temperature is same. Kc remains unchanged, right? So in case Kc remains unchanged, then you can again solve for the equilibrium, that PCl5 gas giving PCl3 gas plus Cl2 gas, right? Start, reacted, produced an equilibrium. So here 4 moles of PCl5 to start with, nothing of PCl3 and Cl2, and this time the volume of the vessel is 1 liter. So not a problem. See, this is minus Y plus Y plus Y. So 4 minus Y, right? I'm doing mole analysis over here only. I prefer doing mole analysis. 4 minus Y, Y and Y. So as a consequence, what is it that we end up with? We get that y into y upon 4 minus y, and volume is 1 liter, is equal to the Kc value that we have right there. From here, you can solve for y, and the answer that you need to report is the degree of dissociation. Degree of dissociation, you remember the formula? Alpha, it was moles reacted upon initial moles, right? This was the definition of degree of dissociation. So here, the answer that alpha will be moles reacted y upon initial moles, that is 4, right? Okay, next question. Now, this question is saying that for the reaction, the equilibrium steam hydrogen mixture was found to be 40% of 40% H2 by volume, and Kp is being asked, right? Now, when you notice this reaction, well, if you start to solve by basics, okay, what do I mean by basics? Right, we write the reaction, then follow the format, right? We would take more time. Okay, now, how do I know that? That is something which, because I have practiced so much that when I read the question and I try to do a couple of steps mentally, that, okay, ye diya hai, and then start reacted, produced, and equilibrium likhunga, so I realize that, solid and liquid are present, and they are not going to be relevant. What is going to matter is these, and their, ratio is what is going to be related to Kp. And already a percentage composition is given to me. So rather than getting into the entire basics, I can have a faster solution by saying, notice karna yahan par, that Kp will be equal to partial pressure of H2O raised to the power of 2 upon partial pressure of H2 raised to the power of 2. And bola ja raha hai H2 is 40%, right? By volume for gases is by moles only. Okay? That is some completely a thing that you'll have to, you have seen many a times, and I have told you that whenever gases ka composition is given by volume, you just take it to be by moles. Okay? Don't confuse anything else with it. So H2, that is the gas which is 40%, and H2O, that is the remaining gas, will be 60%, right? So this is the ratio of their moles, and moles are going to be proportional to the partial pressure, right? So with this understanding, you will get your answer as 3 by 2 ka square, or you can say 9 by 5, that is 2.25. So this is the faster answer that I have shown you. If you were to go by the basics, okay, you will still get the answer, no doubt. You will get the answer. You will just take more steps. You will have some variables, then solve for those variables, and once solve for those variables, then find the expression of Kp. You are certainly going to get the answer. Then next question, it's okay. Question number 6 is really, really difficult. Okay, it's a pretty challenging question because it's a question which deals with simultaneous equilibrium, right? So you would have understood that there is one reaction which is NH4I solid dissociating into ammonia and HI. Right? And after that, there is this another reaction where HI is further dissociating into H2 and I2. Now, let me read the question in a step-by-step manner, line-by-line manner, and try to answer it going in a way like you would do it. So excess NH4I solid on rapid heating in a closed vessel develops a constant pressure of 4 P0 owing to partial decomposition of solid into NH3 and HI. So constant pressure of 4P naught, right? This means that this is the P total at equilibrium. So solid, nothing. Solid changed into some solid dash, don't care. Now this will be 2P naught and this will be 2P naught such that the total is 4P naught, right? And based on this, you can gather that the Kp of this reaction will be 2P naught into 2P naught, right? Upon solid का activity हम लोग बन लेंगे. So that is 4P naught square. Correct? Now, once we get hold of this, okay, here there was no simultaneous equilibrium. Okay, this was just plain simple one equilibrium till this point. After this, right? यहाँ पर जो statement लिखा है इसके आगे क्या लिखा है that this pressure changes. What happens to it? It gradually increases because of HI dissociating into H2 and I2. And the final pressure at the equilibrium is 5P naught. Now, what you can do is either continue with this, that because of this reaction, HI further starts to dissociate, and as a consequence, there is a shift in this initial equilibrium also. Or you can just take a fresh start, right? So solve for simultaneous equilibrium using the approach that we have studied in the lectures, right? What is that approach? You write the reactions, right? So first we'll write the reactions. NH4I solid is giving NH3 gas plus HI gas, right? And then you also write the second reaction, that 2HI gas is giving H2 gas plus I2 gas, right? Iska Kp is, we have something solved for already, 4P naught square, and iska Kp is what is being asked. Now solid, okay, we start to analyze these reactions one after the other. So solid dash, right? Say X and X. Now for this X, right, we say X nothing, right? This is our start and this is our equilibrium. And X minus 2Y, Y and Y. Now before we start solving it, we need to ensure that the concentration of the common species, which is in this case HI, is same throughout. So यहाँ पर I will do X minus 2Y. Right? So we have two variables now, X and Y. How do we solve for them? One equation is this Kp. So 4P naught square will be equal to X into X minus 2Y. That is going to be our first equation. Is there another piece of information that is given in the question? Yes, it is that the final pressure is 5P naught, right? So final pressure is the P total of both the equilibriums combined, like, so it will be partial pressure of ammonia plus partial pressure of HI. Right? Don't count HI two times just because it is present in two reactions. No, it's just one species that is common throughout, right? So don't double count it. Partial pressure of H2 plus partial pressure of I2. So it is X plus X minus 2Y, Y and Y. And this has been given to you as 5P naught. Right? So this is your second equation. Based on this, you will get your answer of X and Y. Right? Solve X and Y. And then you will get the expression of Kp. Kp is Y square upon X minus 2Y ka whole square. Right? So you will be able to solve for it. Okay. Next question. Question number 7 is related to ammonium carbamate decomposes as this compound for the reaction Kp is given to you. And it is mentioned if we start with 1 mole of compound, the total pressure of equilibrium would be. So I think the question is very easy. Like it is one of the easiest questions that is there in this section in the booklet, right? So the reaction is like already written in front of you. Let me use some copy paste. And start, it has been given 1 mole, nothing, right? And at equilibrium, say this will be 1 minus x, x and x. But of course, you have to remember that this is solid, right? So these don't mean anything to you, right? They're just solid. Kp will be equal to what? Partial pressure of ammonia raised to the power of 2 into partial pressure of, okay, this will be, sorry, 2x, partial pressure of CO2 raised to the power of 1, right? So rather than doing mole analysis, let's say if I did partial pressure analysis, right, that would be fine. Like I don't need to write moles over here. I would write just solid and write over here solid dash, right? Solid dash, and x represents the partial pressures only, right? Partial pressure of CO2, 2x represents partial pressure of ammonia. So 2x ka square into x, and P total will be of course 2x plus x, that is 3x. So yahan se you get the value of x and you substitute over here and get your answer. Question number 8. Okay, a good question. Certainly a good question that would require you to go through each and every line carefully. So in this case, okay, let me call this as case 1, or because I have already read the question. So you have vessel 1 and vessel 2, right? Those are the two scenarios. So I will first chalk out what is happening in vessel 1. So NH4HS dissociates to give you NH3 gas and H2S gas. Where did I get that reaction from? Well, it was not mentioned, but I could read the reaction question, and it was mentioned that NH3 and H2S are the products. Now, dissociates in the presence of 0.5 atm, right? So to start with, right, you have 0.5 atm ammonia gas, right? So then some reactant produced would happen, right? Some amount will change. This will become solid dash, right? Let me directly write it. That at equilibrium, this will be solid dash. This will be 0.5 plus P, and this will be P, right? Now, it is mentioned that at equilibrium, the partial pressure of H2S is 1.5 atm. So you get the value of P, and as a consequence, you get the Kp of the reaction. Kp will be, that is something which is being asked in the question. So Kp expression will be 0.5 plus small p, that is partial pressure of NH3, into partial pressure of H2S. So this will be 2 into 3 by 2, that is just a minute, 0.5 atm at equilibrium. Pressure due to ammonia is equilibrium is 1.5, right? So P is 1.5, 1.5 plus 0.5 is 2. So Kp is coming out to be 3. Yeah, correct. So that is the value of Kp that is being asked. Well, not Kp is being asked, but this value of Kp will certainly come of use to us. How? Let's see. So vessel 2 is there in front of you. Now in vessel 2, which is mentioned, initially evacuated. Right? Initially evacuated means there is nothing inside. And temperature is same. Temperature is same means the same K value for the reaction is going to be there. Right? So you have the same reaction. Let me just Control C, Control V. And the Kp value over here is 3. And here, this time, there was solid, nothing, right? At the start, right? Initially evacuated vessel. And at equilibrium, you will have solid and say capital P and capital P. Okay? Right? Or, it is being said that the total pressure is P naught. So total pressure is P naught. That means this will be P naught by 2 and this will be P naught by 2, right? Because P total is P naught given in the question. So here 3 will be equal to P naught by 2 into P naught by 2 implies P naught will be equal to 3, or you can say 2 times root 3, right? 2 times root 3 ATM. Now, apart from this P naught value, it is also being asked what is the weight ratio of ammonia and H2S in vessel 1. Right? So let's head back to vessel 1 again. Let me create some space over here. In vessel 1, you are being asked this gamma value, which is weight of ammonia upon weight of H2S, right? Weight of NH3 to H2S. So this will be moles of ammonia into its molecular weight, that is 17, and moles of H2S into its molecular weight, that is 34. Right? And moles are proportional to their partial pressure. So you can write this as partial pressure of ammonia upon partial pressure of H2S into 17 by 34. Now the partial pressures, as you can see over here, of ammonia is 2 atm and that of H2S is 1.5 atm. And yahan par you get this as 17 upon 34 as 1 by 2. Right? So upon solving, you get the answer as 3 by 2 atm. Not atm actually, just 3 by 2. It's a ratio only. So you get the value of P naught as 2 root 3 and gamma as 3 by 2. Okay. Then let's talk about the 9th question. Again, a good question and lengthy question. You will have to check each and every option one by one. However, the options are of such a nature that you need not go and check each and every value. You need not calculate the complete answer. Let's see how that happens. Let me solve if I was you and trying to understand the question. So solid ammonium carbamate, right? Make a habit of underlining, or highlighting, or doing some scribbling of the question, where so you can avoid careless mistakes. So solid ammonium carbamate is heated in a initially evacuated vessel, right? And at equilibrium, the pressure was P naught. Okay, so let me find out the reaction. Here, the option comes of help to me, right? This is my reaction. Let me take some help. Now, let's analyze this reaction. This is solid, as we can clearly see. And at equilibrium, right, this will be some solid dash, we don't care. This will be 2P and this will be P, correct? And in fact, the total pressure is given P naught. That means this will be P naught upon 3 and this will be 2 P naught upon 3, right? Because it is mentioned that the total pressure is P naught. Now, based on this, you can get the value of Kp. Kp will come out to be 2 P naught upon 3 ka square into P naught upon 3, which is 4 P naught cube upon 27, right? So Kp value as 4 P naught cube upon 27 is definitely something to look for in the options. Now, it says the volume is halved. Right? So it's a disturbance that is happening over here. And then a new equilibrium is established. Taken. वैसे तो like given the data, you can actually solve the entire new equilibrium. What will be the disturbance, what will be the shift, what will be the final equilibrium, and solve for the variables. However, when I look at the options over here, you can see that at the new equilibrium, that is T equal to T naught, they are asking subjectively what will happen to partial pressures. Will they be more or less than certain values? So let's look at our analysis and see if we can answer without complete solving, right? So you have, let me rewrite this. You have initial equilibrium, which is solid, 2 P naught upon 3, right? And P naught upon 3. Then there's a disturbance. The disturbance was an abrupt change in volume. The volume gets halved, right? I don't care about the solid. Because the volume gets halved, the pressures are going to get doubled, right? Abrupt change. And now a shift is going to happen, right? And increasing pressure will shift the equilibrium towards less gaseous moles, that is leftwards, right? In this case, the shift is going to be backward. So this is going to be, say, something minus 2x and minus x, right? So new equilibrium would be 4 P naught by 3 minus 2x and 2 P naught upon 3 minus x. Now, based on this, you can actually solve for the value of x using the equilibrium constants that were there, right? That we have mentioned above, that we have calculated above. Or you can look at subjectively at the options. Is partial pressure of ammonia and CO2 greater than 2 P naught? Right? If I add them up, this will be equal to 2 P naught minus 3x. Right? P total is equal to 2 P naught minus 3x. So certainly, this is not the answer, right? Is the partial pressure of ammonia less than 4 P naught by 3? Right? The option seems to be correct. Like you can look at partial pressure of ammonia, it is 4 P naught by 3 minus 2x, right? And if you look at the Kc value, right, and use that Kp Kc relationship, here we actually see that delta Ng value is 3, and this does look as the correct relationship, Kp Kc relationship. So yes, this option will be our answer. Okay, let's look at the next question. That is the 10th question. Now, in this, 3 moles of PCl5 gas and 4 moles of CO2 gas is introduced in a rigid vessel of capacity V liters, and on heating, 2 equilibriums are simultaneously established, right? And you can see something in terms of X and Y is being asked in these options. So that's fine. We know how to work with simultaneous equilibriums. So let's write those simultaneous equilibriums, right? So you have your approach. You first write the equation and then you do the mole analysis, right? So let's do that. Yahan par you have 3x moles of PCl5. Okay, this should be PCl3, not Cl2. PCl3 should be, not PCl5. And you have nothing of PCl3 and Cl2. So 3x minus, say, P and P. And here you have 4y moles of CO, and Cl2 we are taking it to be P and nothing of COCl2. Then 4y minus Q, P minus Q and Q. Now we ensure that the common ion concentrations are same throughout. What is the common ion, or sorry, common species throughout? The common species is Cl2. So we ensure that we write it correctly. So we'll write it P minus Q over here as well. Right? That is our common species. Is there any other common species? No, not really. Right? Now, given this understanding, let's see what is it that we can do for these options. We'll check them one by one. And there is a certain data that is also given to you, that the concentration of Cl2, that P minus Q upon V is equal to X minus Y upon V, right? As per our analysis, concentration of Cl2 is P minus Q, right, moles upon volume, and it has been given as X minus Y. So yahan se you can see that P can be written as X and Q can be written as Y. Okay. This is a possible solution, that P is equal to X and Q is equal to Y. Now with that in mind, if we look at another data that is given to us, that will make us for certain sure that what is P and Q. Okay, let me actually not just do the comparison. Let me put the equations also. So PCl3 and COCl2 concentration. PCl3 concentration and COCl2 concentration. PCl3 is P by V and COCl2 is Q by V. Right? That makes it P plus Q by V. And this has been given to us as X plus Y upon V. Now, two equations, two variable, we can be for sure certain that P is equal to X and Q is equal to Y. Right? That is something that we can be 100% certain now. With that given, now you can solve for the expression of K1 or K2. Right? You just have to put the values of P and Q, and whatever the options are asking you, right, you can solve for them as well. Okay. Then next question is based on LCP, right? And it is about solubility of a substance which dissolves with decrease in volume. Right? So there is some substance. It is solid right now, and when dissolved, that substance becomes dissolved substance. We call it aqueous, right? And the equilibrium is being discussed, that it dissolves with decrease in volume, right? So this is higher volume and this is lower volume, and absorption of heat, right? So delta H of this reaction is positive. Now it is being asked that the reaction or the solubility means going in the forward direction, right? Forward process will be aided how? Now, as you can see, since it's endothermic, right? So if temperature increases, equilibrium shifts forward, right? That is something that we know. What about pressure, right? Since delta Ng is not defined, right? For this case, delta Ng is not defined. What was the thought process that we had studied in class regarding pressure? That if pressure increases, equilibrium shifts towards lesser volume, right? Lesser volume or higher density. So yes, here lesser volume is on the right side, that is in the forward direction. So high pressure as well as high temperature, both are going to aid this reaction in the, or this equilibrium in the forward direction. Right? Okay, then next question. That is the 12th question, where active mass means moles upon volume in liter, basically concentration only, of A, B, and C at equilibrium are given this. And there is some information about the active mass of C and D also. So let's rewrite the equation. 2A plus B is given C plus D. Right? And for this reaction, we are being mentioned that you have 0.5 moles, molar actually concentration directly. So let's write down this is a concentration analysis. You have an initial equilibrium. This is 0.5. That of B is 2 and C is 1. Right? What about D? We don't know. Right? It's definitely not 0. Okay, don't put as 0. Why you can't put as 0? Because initial equilibrium data given, na? How can you have no D if equilibrium is established? There has to be some amount of D, na? So that equilibrium is there. So definitely don't take it to be 0. It is some unknown value, right? And then use this information that active mass of C, right? Initially, the active mass of C was 0.5 molar and D was 0, right? So, okay. That means before the equilibrium, some data is also mentioned, right? This is initial data. So, okay, then let's make space for that initial piece of information. Let me write start. Again, I don't know what was the amount of A. I don't know what was the amount of B, right? There was nothing of D and C was 0.5. Okay. Now, something must have reacted and produced. Like since D was not there, definitely forward is jayega reaction. This reaction is going to go in the forward direction. So say minus 2x, right? Minus x plus x and x, right? And with that, we can see that A minus 2x will be 0.5, right? That is our first equation. Second equation will be B minus x is 2. Third equation is 0.5 plus x is 1, right? So yahan se you will get A, B as well as x ka values. Right? Once you are able to get that, then the rest of the task is easy. Determining whatever is D at equilibrium or A initially and equilibrium constant and so on and so forth. Yeah, isme I think I remember the catch why C option is not correct is because of the units. Okay, that is the reason why C option is incorrect. The value comes out to be 6.275, but as you can notice, the value has the unit has to be just m, not m square. Okay. Then 13th question. So in the 13th question, based on the language of the reaction, language of the question, we determine that the following reaction occurs. COCl2 dissociates into CO and Cl2, right? And 4 moles dissociates in a 20 liter vessel, right? The volume is 20 liter for now. And say this becomes 4 minus x, x and x, and x upon 20 is 0.1. So that means x ka value is 2, right? Now, there are 2 disturbance, and actually let me not use x because there is another x in the question. Let me use y over here, 4 minus y, y and y. So y upon 20, that means y is equal to 0.2. And then there is a disturbance that volume is doubled and X moles of CO are added. Okay, so now let's analyze the equilibrium again with the perspective that the disturbance is going to happen. So you have an initial equilibrium, which is 2 moles COCl2, 4 minus Y, 2 moles of CO and 2 moles of Cl2, and volume is 20 liter, right? Then there is a disturbance that is happening. Like, what is the disturbance that happened? That, suddenly the volume became 40 liters. Volume got doubled. Now, moles पे उसका abrupt change नहीं होगा, right? We are doing moles analysis, right? So moles पे abrupt change नहीं आएगा. So it will be 2 only. This will be 2 only. And of course, I'm just writing the disturbance row. So no abrupt change in COCl2, no abrupt change in CO. No abrupt change in Cl2 because of the volume, but yes, okay. No abrupt change in Cl2, but because of some moles of CO added, right? X moles were added. So an abrupt change of X, I have written over here, CO. Now shift happens. Ab volume की वजह से, as well as moles add करने की वजह से, we'll have to see. So because of the moles added on the product hand side, the equilibrium shift must be backward. And यहाँ पर you can see that the volume got doubled, right? And subjectively, if I was to think of it, the equilibrium should shift towards more gaseous moles, that is forward. Now, contradiction hai, but theek hai, no worries. We don't care. We'll automatically get the answer when we solve for it. So let's assume that this goes in forward direction. So this would be, say, minus Z. We have already used Y above. So minus Z. So this will be plus Z and plus Z. So what will happen at the new equilibrium? This will be 2 minus Z. This will be 2 plus X plus Z. And this will be 2 plus Z. How do we solve for X and Z? So we have information that COCl2 concentration is 1 by 16. Right? So 1 by 16 is equal to, that's our first equation, 2 minus Z upon 40. Don't forget about the volume. This is the concentration that is given. The second is from the expression of Kp. Right? So यहाँ पर Kp, which we got, was 2 into 2 upon 2 into 1 by 20. So that same Kp we are going to use over here, right? 1 by 10. Right? This is the value of the Kp that we get over from here. 1 by 10. That is what we are going to use over here as well. Is going to be equal to 2 plus X plus Z into 2 plus Z upon 2 minus Z into 1 by 40, the new volume, right? Here you will solve for what is X and what is Z, and then get all of your answers, right? Great. Let's look at the next question. That is the 14th question. Now, in the 14th question, a vessel was found to contain equal mass of CO, CO2, H2 and H2 at time t equal to T naught, right? So T naught per the mole ratio of CO2 upon mole ratio of H2, right? Because they had equal mass. So what it would be? Say their mass was M, so M by 44 upon same mass M divided by 18. So we'll get the answer is 9 by 22. And time t equal to 3 T naught, right? The same ratio is what is there, right? That is what is given in the question, that the ratio of moles of CO2 to H2O, right, is 9 by 22, right? What does that mean? That means that equilibrium was already established. Right? Equilibrium was already established. That is, time T naught पर भी equilibrium था. T naught, 2 T naught, 3 T naught are all at equilibrium. So with that knowledge that you are being armed, you can determine the rest of the things. That's not really a problem. You have been given the mass of each of these substances same. So it is m, say m at equilibrium. You can certainly work with moles. What would be the moles? Moles will be say m by CO ka molecular weight is 28, H2O ka molecular weight is 18, CO2 ka molecular weight is 44, and H2 ka molecular weight is 2. So you get the moles, and based on moles, you can get whatever Kc, Kp, well, not Kp, but Kc, yeah, Kp actually, Kc same hoga, delta Ng 0 hai yahan par. So Kp, Kc, and whatever mole ratios, mole fractions are being talked about. Okay. All right, now in one or more than one option correct, let's look at the first question. Now, these questions are based upon LCP, Le-Chatelier's principle. And the options are, to be assessed one by one. Right? So we read the question, that's a gas phase reaction, right? That means delta Ng of this reaction is -1. And it's an exothermic reaction that has been given to you. And it is being asked the equilibrium concentration of C2H4 can be increased by. This means we want the reaction to shift backward. Right? Now, which of the option is assisting in it? Well, we assess them one by one. Temperature increases. Now, because it's an exothermic reaction, right? Because delta H is less than 0, that means increasing temperature would decrease K, shift equilibrium backward. Right? So this option matches. B option talks about decrease in pressure. Right? So since delta Ng is negative, right? You can think subjectively as well as numerically. The subjective way was decreasing pressure, the equilibrium will shift towards more gas moles, that is in the backward direction. Or you can think from a numerical perspective that delta Ng is negative, right? So Q will be, or Qp will be equal to Qn into Pt raised to the power of -1. So it is in denominator, right? And decreasing denominator will increase Q, right? Pt decreases, Qp increases, becomes more than Kp. As a result, shift is again backward, right? So this is also a correct option. Removing H2, right? How do we judge removal of H2? Well, again, you notice Q is products upon reactants, right? Now, the H2 is reactant, so you are decreasing the reactant. You are decreasing the denominator. As a result, Q value would increase, right? Q becomes more than K, right? Implies the shift is backward, right? Now, adding some C2H6. So the assessment is in the same manner how we had talked about the C option, right? The same way Q is equal to products upon reactants. And in this case, C2H6 is actually the product and we are increasing it, right? So that would increase Q, right? And the entire same thing is applicable that yes, the reaction will shift backward. So all the 4 options here are applicable. Now, second question. Second question is definitely something which would require you to be a little more aware because of the language, right? NaNO3 is solid. NaNO2 is left behind, means that is also solid, and O2 is liberated, that means it is gas, right? So NaNO3 solid is in equilibrium with NaNO2 solid, right? And NaNO2 solid and half O2 gas, right? Now, adding solid species is not going to, adding or removing solid species, right? These are solid. So that is not going to help our equilibrium shift, right? So they remain as it is. What about the increasing temperature? So yahan se again, you get the hint that it is heated. This means it's an endothermic reaction. So increasing temperature would favor the forward reaction, right? It will increase the value of K, shift the equilibrium in forward direction. Okay, what about the D option? For D option, we judge based on delta G. Delta G here is plus half, right? It is positive, right? Increasing pressure will shift the reaction towards lesser gaseous moles, that is in the backward direction, right? Or you could do it numerically also, right? Delta Ng is positive, matlab you will get that P is in numerator, right? So if you are increasing pressure, that means you are increasing Q, implies Q becomes more than K, implies you can shift backward, right? The shift will happen in the backward direction. Okay, next question. Third question. So it is again an equilibrium in which it's present in a closed container and inert gas helium is introduced, right? So when it's mentioning closed container, we can take it to be a constant volume vessel, right? And when you add inert gas at constant volume, right, what is going to happen? Right? There is no effect to the equilibrium. So concentration of SO2, Cl2, SOCl2 does not change. As a consequence, B, C, and D, because the equilibrium is not shifting, right? There is nothing that is going to happen to this equilibrium, right? Okay, let's look at the next question. Question number 4, right? So what is there in the fourth question? So if you notice, again, it's a gas phase reaction. And we are being asked that forward reaction is favored by what? Now, A option is not correct because as you would have gathered from your lectures, your notes, that inert gas at constant volume means no effect, right? The equilibrium is not going to shift forward or backward. Introducing chlorine gas at constant volume, well, again, you have to think in terms of Q. Q is products upon reactants, of course, raised to the power of their coefficients. And you are introducing chlorine gas. Chlorine is a product. So you are increasing chlorine, that will, as in increase the product, it will increase the value of Q. And it is going to shift the reaction in the backward direction. So B option is also not the answer. We are looking for something that shifts the equilibrium in the forward direction. Okay, let's look at C option and D option. C option, D option actually are going to be the same thing, because inert gas, when introduced at constant pressure, results in increase of volume only, right? And yahan par, as you can see, delta Ng is positive, is 1. So when we say QC is equal to Qn, volume comes in the denominator, right? V raised to the power of minus delta Ng. So yahan par V comes in the denominator. Now, what we are seeing is that increasing volume would decrease Q. As a consequence, it will shift the equilibrium in the forward direction. So both C and D option are our answers. And increasing PCl5, right? So it is again analyzing in terms of Q being product upon reactant, right? And yahan par you are saying that increasing PCl5 would increase the denominator, which would decrease the value of Q and shift the equilibrium in forward direction, right? So that is also the correct answer. Now let's look at fifth question. For this reaction, what is going to be the effect? Okay, CO2 is going to be, it is asking CO2 to be increased. That means we are looking for forward shift, right? That is how CO2 ka amount will increase. Catalyst, they do not affect the equilibrium. They just alter the time taken to achieve the equilibrium. Adding inert gas, well, yahan par it is not mentioned that we are adding it at constant volume or at constant pressure. The thing is that it won't matter. Okay? Here at constant volume, we already know that there is no effect. And constant pressure, as you can see that delta Ng is 0. So here also we can see that there will be no effect. Right? So this is also not an option. Decreasing the volume of container, again, no effect, right? Because of the fact that delta Ng is equal to 0. And increasing the amount of CO, well, yes, it is going to shift the reaction in forward direction, right? You are increasing the reactant, so it is going to shift the reaction in the forward manner. Let's look at question number 6. Which of the following is correct about chemical equilibrium? Well, first is absolutely correct. This is from thermodynamics, that a process under constant T, P conditions is at equilibrium, and the condition for that is the change in Gibbs free energy delta G is 0. B option is also correct. Equilibrium constant is independent of initial concentration, right? Equilibrium constant depends only on temperature. That is its fundamental factor. Catalyst has no effect on equilibrium state. Yes, the alpha value or K value does not change upon introducing a catalyst. And reaction stops at equilibrium. Well, no. Equilibrium is dynamic in nature, right? So the rate of reactions don't become 0, right? They just become equal and opposite. Forward reaction as well as backward reaction. 7th question is a bit of a math, right? That you'll have to apply over here. So you write down the reaction, and based on that, you can quickly understand 1, 0, 0, 1 minus alpha, alpha and alpha, right? So this was your, say, mole analysis of start and equilibrium, where alpha is your degree of dissociation. Now, you are being asked to relate alpha with pressure and volume. So that comes from this relationship, Kp is equal to Kx into P total raised to the power of delta Ng. Right? So you can see Kp will be equal to Kx. So you will have alpha upon 1 plus alpha into alpha upon 1 plus alpha divided by 1 minus alpha upon 1 plus alpha. So these are the mole fractions of the species raised to the power of their coefficients into P total raised to the power of delta Ng, which is 1. Right? So yahan par when you simplify it, you get Kp as alpha square upon 1 minus alpha square into P total. And since it is mentioned that alpha is much, much less than 1, you can put 1 minus alpha square as 1 only, right? So you can see that alpha is equal to under root of Kp upon P total, right? Or you can see that alpha is proportional to 1 upon square root of P total, right? And as a consequence, because temperature is constant and pressure and volume are inversely proportional to each other, so alpha would be directly proportional to the square root of V, right? Kp is a constant only, right? It only changes with temperature. So this is going to give you the correct answer as C option and D option. Then we look at the 8th question, right? So the 8th question is about considering the reaction below and what would proceed to the right by increasing pressure, right? So P increases, right? And we know the shift is towards lesser gas moles, right? So yahan par when we read in the A option, the lesser gas moles are on the right hand side. So yes, it is actually forward. For the B option, the lesser gas moles are on the left hand side. So it is a shift backward. On the C option, the lesser gas moles are on the right hand side, right? You can see 1 plus 2 is 3 and here 1 plus 4 is 5. So this is going to be forward only. And here no shift because delta Ng is 0, right? Both the sides are equal moles. Okay, then next question has an interesting language where it talks about the shift being undeterminable, right? So the shift being undeterminable will be the scenario where, there are two disturbances that are being done and they're contradictory, shifting the reaction. So addition of O2 will shift the reaction forward, and decrease in volume, right, will shift the reaction towards decrease in volume sure with lesser gaseous modes की तरफ shift करेगा, right? So this is going to take it in the backward direction. But let me double check numerically also. Here delta Ng is negative, so V will be in numerator, and you are decreasing V. Yeah. So I think double checking helped me. So by double checking numerically, I understood that delta Ng is negative. V is going to be in the numerator in the expression of QC. QC is equal to Qn V raised to the power of minus delta Ng. And I'm decreasing the volume, so I will be decreasing Q. As a result, the shift will be in the forward direction only. Right? So this is not contradictory. Here the shift is determinable. Addition of CO will again shift the reaction in forward direction. Removal of CO, like removing the product, will also shift the reaction in forward direction. Right? I judge this based upon Q being written as products upon reactants. Right? Increase in temperature, right? Because it is plus heat, that means it is exothermic reaction. Right? यहाँ पर heat release हो रही है. So the increase in temperature is going to shift the equilibrium where? It is going to shift the equilibrium in the backward direction. And decrease in volume, we just identified above that it was forward. So yes, there is a contradiction, and this means that C option, the shift is undeterminable. Addition of CO is going to shift the equilibrium forward, and increasing temperature, as we just discussed, is going to shift the equilibrium backward. So contradiction appears, and hence D option will also become part of your answer. For the 10th question, it's relatively easier, right? You have to analyze this equilibrium forward direction. Inert gas introduced at constant volume, no shift. Introducing Cl2 will shift the equilibrium backward, right? So this is also not the option that we are looking at. Introducing inert gas at constant pressure, right? So here this will result in increase in volume, right? And since delta Ng is positive, right? When I look at the expression QC, Qn, it will come V raised to the power of +1, right? In the V will be in the denominator because delta Ng is positive, right? And in adding inert gas would increase the volume. That means Q will get decreased and the shift will be in the forward direction. So yes, this is favoring it. And D option is actually the same, increasing the volume of container. Right? So these are one or more than one choice questions. Now, coming to the comprehension type questions. So in the first comprehension, as you can notice, there are certain questions which are based upon the concepts of chemical kinetics. Like they are mentioned over here, but they are based upon the concepts of chemical kinetics. So I would recommend, you can skip these questions and learn or redo or rework these questions once you have understood the concept of kinetics, like both the first and the second question. The third question is something, the second question you can answer if you got the first question based upon the fact that delta G naught is equal to minus RT ln K, right? But the fact is that the first question requires knowledge of chemical kinetics, so we are skipping it. Third question talks about addition of inert gas at constant pressure at a given temperature, right? So here, as you can see, for this reaction, delta Ng is 0, right? Since delta Ng is 0, so we'll say that inert gas being added at constant pressure will not have any effect on the equilibrium, right? The fourth and the fifth question, right? They are about if the volume of the vessel becomes double, right? Again, no effect on Kc, right? Because it depends on temperature, and there is no shift, right? No shift of equilibrium as well. So you will reject A and B option also. The equilibrium constant Kc or Kp increases with. So you will have to actually look at the question and figure out whether it is an endothermic or exothermic reaction. Well, based on this diagram, we are able to judge whether it is endothermic or exothermic. But again, I would ask you to refer kinetics. How will we judge from this diagram? Well, actually, you can judge because reactants and products, this is the energy scale. You can see energy of products is less than energy of reactants. So delta H, which is EP minus ER, is going to be negative. That means it's an exothermic reaction. So while with decrease in temperature, the Kc and Kp value will increase. Right? We would have answered this by looking at the diagram. Although we will look at this diagram, we have not done this in notes in lectures, but we'll look at this diagram in chemical kinetics chapter though. Right? So you will have an understanding of what this all mean, reaction coordinate on the x-axis, energy on the y-axis. Okay. Talking about the next comprehension. So in the next comprehension, again, there are certain questions which are from chemical kinetics. They are not supposed to be done before we study those concepts in chemical kinetics as such. But some of the questions can be answered. So when you are looking at this expression, right, this is nothing but something that we have already done in class, right? Ln Kp was equal to minus delta H naught by R into 1 upon T plus delta S naught by R. So if you differentiated both the sides with respect to T, so d of ln K by dt would have become equal to delta H naught by R, and 1 by T ka derivative will be minus 1 by T square. So minus minus became constant, and of course delta S naught by R was constant, so it became, this ka derivative was 0. So that is what is written over here, and it's given this name Van 't Hoff equation. Right? Now, look at here that the graph is between log Kp, right? So that is your y-axis, right? And 1 upon T is the x-axis, right? So this is what we are looking at. This is the y-axis, and 1 upon T is the x-axis. So what is your slope? The slope is minus delta H naught upon R, right? So line 1 has positive slope, right? And line 2 has negative slope. So enthalpy change is mentioned positive. That means we are looking for a negative slope. So that means it is line 2, right? Second thing is something that you know from your LCP discussion, that for exothermic reaction, Kp will decrease with increase in temperature, right? Again, third question, no need to discuss the word activation energy right now. As I said, refer kinetics chapter. Then the fourth question, that is just a Kc-Kp relationship. So that is something that we have done in the class notes itself, right? Kc-Kp relationship. Now let's look at the next question. All right, let's move on to the next question, which is a paragraph based upon the concept of relative humidity, right? So it's a passage-based question. Now, this is something which requires an entire understanding of relative humidity concept. I have covered it in lectures, so I'm not going to take it over here because it's a bit lengthy. It will take 10 plus minutes in this concept only. So I recommend you go to the playlists under, in my channel, and in the chemical equilibrium playlist, watch the lecture 5 in the beginning only at 2:58, and you will find the explanation for the concept of relative humidity and solved each and every question in this passage. Moving on to the next passage. Here we have, for a gaseous reaction, right? You have been asked that what are the relationships that are going to hold true. So these are something, again, you would have seen in the notes itself. We have done these relationships. Kp is equal to, or Kc is equal to Kp raised to the power of, Kp is equal to Kc into RT raised to the power of delta Ng, right? That is one of the relationships, and between Kp and Kx, we get the relationship. So Kp is equal to Kx into P total raised to the power of delta Ng upon, okay, right, P total, and Kp is equal to Kc into RT raised to the power of delta Ng, right? So use these to find out which expression matches. Then in the second question, here we can see that delta Ng is positive, right? And Kp upon Kx will be equal to your P total raised to the power of 1, right? Delta Ng is 1. So for the reaction, this reaction Kp is greater than Kx, right? And Kp upon Kx is greater than 1 is obtained in which case? So the only option here is D option, where the pressure is 2 atm. The third one is also answered in the same manner. Then let's look at the next passage, and it's based on thermodynamics, right, where we studied how temperature affects equilibrium constant, right? So pretty straightforward relationship. We have derived this and discussed this in the class as well. So you'll have to compare. Okay, you'll have to compare the two equations, and based on that, come up with the answers, right? So here you can see that the value delta S naught upon R is comparable to 2, right? So delta S naught is equal to 2 times R. Then the second question talks about the value of K equilibrium always increases with increase in temperature. No, depends upon whether the reaction is endothermic or exothermic. Exothermic reaction, K equilibrium increases with decrease in temperature. That is correct. For endothermic, K equilibrium increases with decrease in temperature. No, not correct. Right. For exothermic reaction, the slope, right, the slope is minus delta H naught by R, log K versus 1 by T का graph, or you can say 2.303 भी लगाना पड़ेगा because it is log, right? However, exothermic reaction, the slope will be negative into negative positive. So this is also an incorrect option, right? Then you look at the third question, in which again there is a graph that is given to you. So not really a problem. You can simply observe the graph and understand that the slope here is slope here is plus 1, and that should be equal to minus 2.303 into delta H naught upon R, right? Now, since the options given here are in Joule, right? So the value of R that you'll have to choose is 8.314, right? So based on that, the answer that you're going to get is going to be the value of delta H naught, right? Slope here, why did I put slope as 1? Because it is tan 45 degree. The angle is given to you. Okay. Then next question is again a reaction given for which equilibrium constant at 2 different temperatures is given, and you are being asked to calculate the enthalpy change for the opposite reaction, right? So you use the expression ln K2 by K1 is equal to delta H naught by R into 1 upon T1 minus 1 upon T2. Based on the units, right, please understand what the correct expressions or what the correct values you have to put. So here ln 4 upon 1 will be equal to delta H naught upon R ka value in calories is 2 calories per mole Kelvin, and temperatures you'll have to put in Kelvin, right? So 1 upon 300 minus 1 upon 320. And this is going to give you the delta H naught for the reaction. And the answer is going to be minus of that, right? Because of the fact that the reverse reaction ka enthalpy change is being asked. Now let's quickly look at the matrix match, in which you have a relationship between Kp and Kc for these reactions, right? So Kp is equal to Kc into RT raised to the power of delta Ng, right? So you will have to get the relationship of delta Ng for each of these cases. So here delta Ng is 1, right? Here delta Ng is -1. Here delta Ng is 0. And in this case, where there is aqueous species present, so we say delta Ng is not defined. Since delta Ng is not defined, right? You have both gaseous and aqueous species. You don't have Kp or Kc defined for such reaction. Here it will be in terms of both concentrations and partial pressure that you'll have to write the equilibrium expression. Then the second question is, again, you are supposed to determine the units of equilibrium constant, right? These are the units of equilibrium constant. So based upon the delta Ng value, you can comment on the values of the units on the right hand side, right? So pretty straightforward, nothing much to work over here. Now this question is, the third question is something which requires you to use certain approximations, right? Alpha much less than 1 approximation. So what you'll have to do is analyze each reaction one by one and come up with the answer of relationship between Kc and alpha, right? So here again also assume that the volume is 1 liter. Like you will have to go with that assumption. Otherwise, the volume term might also appear. So 2x is giving y gas plus z gas, right? So 1, 0, 0, 1 minus alpha, right? Put alpha over here because alpha is a degree of dissociation, right? So it is moles reacted upon initial moles. And here you should get alpha by 2 and alpha by 2. Right? So having said that, then you write the expression of K, right? So it will be alpha by 2 into alpha by 2 upon 1 minus alpha raised to the power of 2, right? And since alpha is much less than 1, you can write this to be alpha by 2 into alpha by 2 upon 1 is equal to K. So you come up with the answer that alpha is equal to 2 root Kc, right? That should give you the value. Similarly, you have to approach the other options one by one. So let me do it for the C option. This was for A option. Let me do it for C option again. 3x giving y plus z, right? So 3x gas giving y gas plus z gas, right? Say 1, 0, 0 and 1 minus, right? Alpha only, not 3 alpha, because then 3 alpha would become the degree of dissociation. So here write 1 minus alpha, you will get alpha by 3 and alpha by 3. So again, you get the expression alpha by 3 into alpha by 3 upon 1 minus alpha ka cube is equal to Kc. And then you approximate an alpha is much less than 1. You will get alpha is equal to 3 under root of Kc, right? So that will be your Q option. So इस तरीके से you'll have to check each and every of these options. Now looking at the next one over here, what it is reading is that increase in temperature in the A option, increase in temperature increases K, right? So that means it's an endothermic reaction. Here you can see that higher K or higher temperature K is a lower value. Increasing temperature decrease the K. That means it's an exothermic reaction, right? For a reaction like this, delta Ng is 0, right? You can see here X is solid, so delta Ng is 0. So it is affected by, it is not affected by change in pressure. And here in the last option, in the C option, right? Delta Ng is -1, right? So it is affected by change in volume. Right? Okay. Now, let's look at the next question, fifth question. It talks about the shift in the reaction. So here delta Ng in the A option is 0. So pressure results in no effect. Here in the B option, again, you can see that delta Ng is positive, right? 3 plus 1, that is 4, 4 minus 2, that is plus 2. So increasing pressure would shift the equilibrium towards lesser gaseous moles. Here the lesser gaseous moles are on the left-hand side. So the equilibrium shifts in the backward direction. Now for this reaction, again, temperature is increased and it's an endothermic reaction. So the shift is in forward direction. Right? And pressure is increased. The shift is towards lesser gaseous moles, which is also in the forward direction. Right? So for this option, P comes the answer. And in the last question, in the last option over here, you can see that pressure decrease would cause what? Would shift the equilibrium towards more gas moles, which is backward, right? And increasing the moles of N2, which is like increasing the reactant, would shift the reaction forward. So it means that we'll have to get data to really understand what will happen. Otherwise, theoretically, we cannot predict. Right? So pretty simple, match the columns. Then assertion and reasons. Let's quickly go through them one by one. They generally are quite easy. And the way to answer the assertions reasons is, in a way, you have to read the statements individually, judge whether they are correct or not, and then look for whether the statement 2 is an explanation for the statement 1. So let's do that. The endothermic reactions are favored at lower temperature and exothermic are favored at higher temperature. Well, the statement itself is wrong. When a system in equilibrium is disturbed by changing temperature, it will tend to adjust itself so as to overcome the effect of the change. So the statement is correct. That is LCB. Right? So as a consequence, it becomes D option as the answer. The first option, the first statement is false and the second statement is true. Then let's look at the second one, which talks about what happens to the melting point of ice when we increase the pressure. The melting point decreases. That is what is being said in the statement 1. That melting point of ice decreases on increasing pressure. Now, this is something that we had covered in our notes where we talked about this equilibrium H2O solid and H2O liquid, right? And here we spoke about the fact that between ice and water, ice has lower density, or you can say, my bad. Ice has, yes, lower density and water has higher density, right? And increase in pressure would shift the equilibrium forward, right? So it will result in lowering of the freezing point or melting point. So the first statement is actually correct. And second statement, ice contracts on melting. Well, as you can see, this is higher density. H2O solid is lower density. That means higher volume. And H2O liquid is of higher density means lower volume, right? So it is contracting upon melting. So the statement is also correct. And the explanation is also right, that increase in pressure would shift the equilibrium towards higher density. Then third question. The equilibrium is not affected by change in volume. Well, it is incorrect. Here delta Ng is positive, so equilibrium is going to be affected. Right? Kc of the reaction does not depend upon volume of the container. Yes, this is correct statement. Kc or Kp depends only on temperature. Right. Then let's talk about the fourth statement, as in the fourth question, assertion reason. For a chemical reaction at initial stage, rate of forward is greater than the rate of reverse reaction. Well, that is true. At initial stages, it is, right? And when rate forward becomes equal to the rate of backward, equilibrium is attained. Yes, right. So both statements are correct, but that statement 1 is not the correct explanation for statement. Statement 2 is not the correct explanation for statement 1. The reason why initial rate is greater is because we started with reactants. There was nothing of products, right? So that is the reason why it is correct. So here option B, right, that both statements are correct, but not the correct explanation, should hold true. Then the next statement. For the reaction A gas, B gas, C gas, Kp is equal to 1. If we start with equal moles of all gases at 9 atm of initial pressure, then at equilibrium partial pressure of A increases, right? So you will have to actually look at the Q and the K value, right? So if I, for this reaction, compute Q will be equal to Qx into P total raised to the power of delta Ng. So Qx will be, 1/3 into 1/3 upon 1/3, and P total here is 9 and delta Ng value is 1, right? So we get the value of Q as 3, which is certainly greater than K which is 1, right? So the shift will be in the backward direction, like the reaction will proceed in the backward direction to attain equilibrium. And if it goes in backward direction, then the A value, pressure of A would increase. So yes, the statement is correct. And if Q is greater than K, then the equilibrium shifts backward direction. That is what we used to understand the statement 1 as well. So both the statements are correct, and the second statement is a logical explanation for the first statement as well. Then we look at question number 6. Here it is mentioned that the gas phase reaction PCl3 plus Cl2 giving PCl5 shifts to the right on increasing pressure. Well, increasing pressure shifts the reaction towards lesser gaseous moles. So that is correct. The last statement is actually incorrect. It shifts the equilibrium towards lesser gaseous moles, not more gaseous moles. Then the seventh statement, or the seventh assertion reason, the equilibrium is not static but dynamic in nature. Yes, that is correct. The physical equilibrium state in which two opposing processes are proceeding at the same rate. So that is correct. And the explanation is also correct that the rate is not 0. Rate forward is equal to rate backward and not 0, right? So it is that both the statements are correct, and the second statement is an explanation, right? Then the eighth one, which talks about if QP is less than KP, reaction moves in the direction of reactants. Well, no, if QP is less than KP, then the reaction moves in the forward direction. The reaction coefficient is defined the same way as the equilibrium constant, but at any stage during the reaction. So that is the correct statement. Right? We need not bother about the link between them because the first statement itself is wrong. Okay. So accordingly, you get the answer. Then in the next statement for the reaction, this, if the volume of the vessel is reduced to half the original volume, the equilibrium concentration of all the gases is doubled. So yes, equilibrium concentration will get doubled because the volume is halved, right? So there will be no change in moles because delta Ng is 0. Delta Ng is 0 implies no shift, implies no change in moles, right? But concentration is moles upon volume, and the volume got halved. So the volume got halved, so concentration will get doubled, right? And the second statement is also correct, that LCP results in shift in direction that tends to minimize the effect of the change or the stress that is happening. But it's not an explanation. No? The explanation was more mathematical in nature, that delta Ng was 0. Right? And then the last one, the 10th one, in which it is mentioned that the equilibrium constant of the exothermic reaction decreases on increase in temperature. Well, the statement is correct, that we have learned from our notes. And this is the relationship, right, that talks about how K depends on temperature. And so our exothermic reaction delta H is negative, which makes this ln K term negative, and that means K2 upon K1 is less than 1. So it's a correct explanation as well. Okay, so this finishes off your Get Equipped to Advanced Valley questions. Thank you.